This is what everyone predicted. This is what all of the experts have been saying for decades. And it's finally here. It's just here.
With FirewatchAI, you can predict the progression of the wildfire spread in a specific location and weather condition. All of this is possible with our machine learning model. Let's see how it works. First, you go to the map and you click on a specific location. This will be the starting point of the fire. For example, let's choose somewhere in Palo Alto. Now, click on Predict Fire Spread. Click on the play button to see how fast the fire spreads at that specific location during a certain amount of time. Notice how the average speed right now is 0.55 miles per hour. You can also change the weather conditions to see how this would affect the average speed of how the fire spreads at that specific location. Predict the fire spread and notice how the average speed right now is 0.76 miles per hour because the temperature and the wind were higher this time. You can also clear the markers and choose a different location. For example, let's choose Colorado this time. Then, we predict the fire spread at this location and notice how the average speed here is 0.42 miles per hour. Also, please check out our resources page at the bottom of our website.
In our project, machine learning was a bottleneck with the most technical challenges. The biggest problems we faced were the issues with finding proper data to train our model. For the machine learning part of our application, we've used a Kaggle public dataset with the data of 1.8 million wildfires. However, the weather data were much more difficult to obtain. After several hours of search, NOAA turned out to be the only free weather dataset. However, they only allow you to download small datasets for very specific searches. Because of that, instead of finding the data for the whole country, we've identified 4 states which have diverse weather conditions but often wildfires: California, Washington, Oregon, and Texas, and manually obtained datasets for each one of them. The next issue was that different meteorological stations were reporting different weather parameters, so we had to parse the data in order to find those that reported all of the temperature, wind speed, and precipitation. Wildfire dataset provided us with 2 labels for our machine learning model: fire size and its duration, which we could have then used to simulate the spread of the wildfire. The weather dataset gave us data points to predict the labels. The tricky part was to combine those 2 datasets because fires were happening with particular weather conditions in different locations and times. Times were represented in a Julian data format, which we had to convert with our own formula. We converted the data from the CSV and SQLite formats into MySQL and uploaded it into our SQL database on Google Cloud Platform. From there, we were able to import the data into Google Cloud Platform BigQuery. We handled all the parsing of the data inside BigQuery with complex BigQuery SQL queries. After having the clean dataset, we've trained the machine learning model in BigQuery using 3 different strategies: deep neural network regressor, XGBoost, and linear regression. It turned out that linear regression performed the best, and we are able to use the BigQuery Node.js API to create an API for our app to predicting the spread of the wildfire. Because of the difficulties of obtaining the data and extremely limited resources and time, we had to trade off many things that would have made our model more accurate. 2 major things that we would be looking to improve would be adding more weather data from more places and from more sparse conditions. We would also look into taking more aspects into account, such as population, nature, and availability of firefighters at a given location. Nevertheless, we are very satisfied with the accuracy that we are able to achieve in such a limited amount of time, and we wanted to thank PenApps and all the sponsors for giving us this amazing opportunity to create Firewatch.